name is Jason. I'm the CEO of DaxBot, and we have Wilkins White, who is, you've been there basically almost since the beginning.
Yep.
With Joseph. So
5 years.
5 years. That's amazing. So yeah, I'd love to just hear, about your background. So yeah, tell us about your background, where you're from, all that fun stuff.
Sure. So I have a bachelor's in science from Oregon State University with a minor in computer science. I spent a semester working in the OSU Robotics lab, which is kind of where I first started, getting into robots.
Yeah.
And I was a member of the OSU Solar Vehicle team, which is where I first really got introduced to kind of applying what I was learning in school to an actual a real-world application. So, EC 111, 112 teaches you what end of the soldering iron to hold, and then at the solar vehicle team is where I learned how to properly tin a wire or work with solder mount or surface mount components, or design PCBs and actually get them printed.
That's awesome.
And then I did my internships in the Bay Area in Silicon Valley.
Yeah, very, very cool. Yeah. So, so with that, how did you get involved with Dax? Or first of all, how did you hear about it, and then what made you want to get involved in the project?
So, as a mutual friend, the Dax project was looking for software engineers.
Okay.
They had gotten started on a mechanical design. There was a model. They were starting on manufacturing to create the DAX as we know it, a little bit different. Some changes. And they had a mechanical engineer, a designer, a few technicians, electrical design was underway, but they needed a software engineer. And there was Joseph, who kind of masterminded a lot of the higher level stuff, but he was also busy running the 17 other companies. So I think what really attracted me to the project was the prospect of kind of mastery in my own domain. Like I was being offered this chance to kind of come in at the ground floor and design almost from the ground up the entire embedded system of this robot, like an actual real project that had constraints, and it just if I'd gone anywhere else, I feel like I would have been working on some isolated part of a whole, and this offer of being able to kind of do my own thing mostly was kind of too good to really pass up.
Yeah, that's so cool. And so for people that don't know, when you talk about embedded, what does that mean from a software? So you're not writing web pages. So.
Right. So embedded. I like to use firmware. So my title is firmware engineer, and I like to describe firmware as the halfway point between software, which runs on an operating system, and hardware, which is what's running the operating system. So you put soft and hard together and get firm.
Nice.
So embedded programming deals with anything where your environment is more tightly coupled to your hardware. Either you're directly managing the registers of a chip, or dealing with a kind of a lower level protocol like I2C or SPI. There's just makes it a lot more. Well, I'd say interesting, but it's you can't take what you write necessarily and just run it on literally any computer anywhere. This isn't a server that you can spin up and design and then just import it to the next machine and it runs.
Right.
You have to really kind of know what's going on, and I've always enjoyed that.
No, that makes a lot of sense. And the fact you know how to hold the right end of the soldering iron.
That's the first part.
Yeah, that's cool. So getting involved in the project makes a lot of sense. I mean, from that perspective, it's you're building something brand new. It's pretty cool and exciting to be able to do that, right? You're not just a cog in the machine. You're like, I'm building the machine, right?
Right.
But what excites you about DAX? As the entity, or as the who we know the personality of DAX is today. What excites you about that?
What excites me the most about Dax is that he's unique. Well, 5 years ago, there really wasn't much on the urban robotics, field besides research. Like OSU at the time had Cassie. There was Boston Dynamics was doing crazy things. I don't think they had quite gotten to parkour yet, but they were working on it. But there wasn't really this. You couldn't just go out and type in delivery robot and see a list of different companies doing this. It wasn't really a thing yet. And what really excited me then and still excites me now is that Dax was doing something different. Like 5 years ago, this was the kind of, oh man, we're gonna build an urban robot, and then as we've seen other groups come up, it's like, wow, we're the only ones who spent 5 years designing a really interesting platform that has a fully articulated neck, has expressions, can communicate non-verbally with you. And just all of that is so much more interesting and gratifying than, working on the next miniature car.
Sure. Yeah. That makes a lot of sense. Miriam just let us know that this is probably coming on from only the left side. So I'm going to spin the microphone.
Okay.
I'm going to kick it out a little ways. And we'll try that.
Okay.
See if that works better. Okay. Let's give it a shot.
All right.
Cool. So what do you see as, since, you're right. I mean, if you look back historically, there's been other people that have been in kind of building delivery robots or something, right? Urban robot space things for, the past several years. But what do you see as the future of robotics? And we were talking about this earlier, before you got here, or before we went live, that there's a difference between a delivery, like a delivery device, like a miniature car, versus like an urban robot that happens to do delivery or something else. So what do you see as the future of urban robotics, and then how does DAX fit into that puzzle?
Yeah, I was actually, last time we were driving back from Portland, and I was, my wife and I were sitting in the car, and it just kind of occurred to me that, we're driving on this massive network of infrastructure that was created to support this piece of technology that started out sort of like, how DAX is today. So in 1908, Henry Ford presented the horseless carriage, the Model T. And I can imagine a lot of the response was, well, I have a horse because I'm a farmer, and I have a carriage to hook up to this horse. Yeah. So why would I need a horseless carriage? Yeah. And then you fast forward over 100 years, and the car is ubiquitous. Most Americans have one, if not more. Mm-hmm. And there's laws and infrastructure that's been developed to facilitate the use of this technology that started out as one company's innovation. Yeah. And honestly, I see DAX kind of going the same way. I can imagine, there's, the obvious of, laws and rules for how robots might interact with each other and other, humans. Yeah. We might even see infrastructure developed specifically for robots. Like we've seen charging stations pop up for cars and for electric scooters or mopeds. Might be charging stations for robots. That is some standardized connector or voltage, etc. We might see different special robot lanes. For example, like underneath roads, we could have tunnels that, robots don't need lights. They're just using sensors.
Yeah.
How DAX ties into this is, I feel like we have a unique opportunity to really shape, especially the laws and how society will interact with robots in the future and how robots will interact with society. I think that's the main role that DAX has to play.
Yeah, and I guess along that same line of like reasoning, obviously you study the history of the Model T and the horseless carriage. There was plenty of people that were not fans, right? And people did not like it, and there was people.
Or internet, the personal computer.
That's right. Yeah.
This is a fad. It's gonna go away.
Naysayers, and then people that just that are probably not nefarious, but like the car. People didn't want it. It was scaring their horses, right? So it was kind of interesting.
You look down on the one person with a Model T going down, and it's loud. It's probably smells, and it's your horse is good enough. Why not use that?
And then the guy getting out and being like, "This is the future," and everybody's like, "Whatever," So in that light, with the laws being passed and different things like that, right? There's not robot lanes to this point. What other hurdles do you see from a human acceptance perspective? Especially because you've worked with DAX, and obviously, working in this space, there's other robots that are out there that are on sidewalks, but it doesn't have the same feeling as when they meet DAX. So can you talk a little bit about that? Like, what is the hurdle, in order for this to become as ubiquitous as a vehicle?
Right. One of the things that we run into the most is the question of, or I guess the response of, "Oh, you're a delivery robot. You're like this delivery robot."
Right.
Insert name here.
Yeah.
And I think there's this real need to kind of allow DAX to define himself, herself, itself as its own entity. We're really trying hard to be unique and do something different, and having where we don't necessarily want to be lumped in with all of the other delivery bots, but when you're designing public policy, then it's really tempting to do that, because hey, this sort of works like a moped. Let's just classify it under moped, and that will that's the majority of what we need to do.
Right.
I think for a little bit DAX was classified as a moped and flew with it.
Nice.
So there's always the struggle of, if you get there first, you get to write the rules, and so we're just making sure that we are staying far enough ahead that we can dictate what those rules will look like, especially moving forward.
Right. Yeah, absolutely. And going back to what we were talking about, off camera, is that there are devices that are meant for delivery, right? Just like that there are classifications of vehicles that are autonomous vehicles that belong on roads, and that's a completely different thing than a device that would belong on a sidewalk or in its own lane. And so the interesting thing is that DAX is an entity that I found anyway that people want to have in their pedestrian space, right? That it's a very interesting thing, and so the more that you explore it, people don't want bicycles on pedestrian spaces, right? I skateboarded in high school, and people don't want skateboarders on their sidewalks or in the mall or wherever, right? But for whatever reason, people are okay with having pets there, right? And so in the same way, what I've noticed is that people are actually accepting of DAX being in this pedestrian space, whether it's downtown Coronado, California, which is a lot busier than hometown Philomath, but even today just going into Corvallis, OSU campus, and having DAX drive on the sidewalks, nobody says that thing shouldn't be on a sidewalk, right?
Mm-hmm.
They fully accept the fact that DAX is part of the urban landscape, and so I think that's pretty cool. And so from that perspective, and your background in engineering, obviously, what can other engineers do? And the thing that I'm thinking about is, when drones first came out, and people just started getting their devices and flying them all over the place, and there were reports of people just not liking it, right? They didn't like drones flying around. So then there's laws and things that were put in place that essentially, drones are very utilitarian, and they could be doing a lot more good with the technology we have today. They could be doing a lot more than what they currently do, largely because of the human acceptance piece, right? So what, from your perspective, are things that engineers and designers can do in the robotics space to ensure that these are more widely accepted, in human spaces?
I think we, speaking for myself and other engineers, we as engineers often run into the hurdle of not considering our product as a human facing.
Sure.
So to take the example of a car, when you're designing a car or a printer or an appliance, it's a tool that has a very specific niche.
Mm-hmm.
So the car, it is bounded by this network of roads. It will never be in your house. It will always be, hopefully.
Yeah.
Right. It will. It's always has a clearly defined network on which, or places that it will be. It has very clearly defined rules, mm-hmm. and it will almost entirely be dealing with other cars. And when it's going down the roads, there's pedestrians, there's cyclists, etc. But most of the rules of the road apply to that car dealing with other cars. And it's very tempting to approach robotics like that. So if you tell an engineer that you want to design a robot and it needs to carry a 2-liter of soda, and it needs to travel 5 miles, and it needs to stop before it runs into people. Usually, invariably, what you'll get is a miniature car that is large enough in carrying capacity to carry the 2-liter, and has a big enough battery to travel the amount of distance you want, and then slap a LiDAR on top, because that's that's the way you solve problems in engineering. You survey the field and find out what's been done. Self-driving cars are pretty amazing. The technology has advanced so far. So let's just take a self-driving car and plop it on the sidewalk, and hey, we don't even have to worry about going at 60 miles per hour. Right. This is great.
Yeah.
But what the tangent, but what we as engineers need to realize is that cars don't have to interact with people.
Right.
But robots do.
Right.
So when you're going down the sidewalk, when you're going down the road in a car, you're not worried about anything unexpected happening. Mm-hmm. Well, you always are, but there's not going to be a car coming down your lane. If there is, you've got other things to worry about. Right. But a robot, what if there is a mother with a stroller that is coming towards you, and she can't move off to the side because maybe her wheels get stuck? The robot needs to be able to give precedence to that human.
Yeah.
Or the other example is early on we went and met with the local chapter of the American Association for the Blind, and we brought Dax to meet them, and drove him around and let them feel him, interact with him, and just got feedback of what do you want to see happen, or how do you want to see this technology progress to make you more comfortable that's happening. What would make you not concerned that if you're going down the sidewalk that a robot might run into you.
Mm-hmm.
And I think that engineers just need to be aware that there's a very large human component when you're dealing with robotics, especially in urban spaces.
Yeah, that's fantastic. Yeah, thank you for giving that history. I didn't actually know we had done that.
Yeah,
that's pretty neat. Yeah. So what other next jobs? So I think I'll answer this question. So somebody asked a question about DAX's storage being expanded. How do you deliver for a party or large family? And so it's a good segue before I ask you the next question. So I'll answer this one. Is that so currently DAX's storage, if you haven't seen it, it actually is inside of his belly. So the whole thing comes out, and that's where it's stored. It's pretty neat because inside on the top we've actually got a heating element, so we can actually keep food hot. You can keep your fries crispy. And then we've actually got a drawer designed with a full actual refrigeration unit built into it. And so we can actually keep things very, very cold on very, very hot days. So pharmaceuticals, or if you just really want your ice cream sandwich to stay just perfect.
We, as soon as the prototype was done, our technician was super excited about it, and he went to the dollar store and he got a box of Hershey's ice cream bars.
Yeah.
And he threw them in there, and he had one of the operators drive a robot just around Philomath, and then came back, and we all had ice cream.
Yeah, because it's about objective and subjective, right? Yeah. I get feedback. That's a good test. So that was kind of the main design, initially, being able to have small carrying capacity. So for large families, things like that, we actually do have designs, and the mechanical engineers are actually working on a backpack prototype if you look at DAX on the back, it kind of looks like a bulge, if you will, that comes out, and that's actually a battery. A lot of people don't know that, but the battery can snap in and out very quick. It's kind of neat. But then right there, where that is going to go, there's the rails and things. So we're going to put a backpack right there, which will expand capacity. And this was actually brought to us from some restaurants that said, "Hey, this is the standard size bags that we use, and if we're sending a meal to a larger family, we need to be able to fit these dimensions, which is larger than a standard paper grocery sack that you find at a supermarket." So we're making those dimensions, and then we have some ideas of how do we pipe in heat and cool into this, and some other things. Obviously, that's a little further down the road. There's also a design for a prototype for a trailer. So there is actually built-in trailer hitch system that we would just need to expand on and create a DAX trailer to do this. These types of things, because a lot of people have asked us about storage capacity in it, and so it's finding what tools that could DAX use, because again it's changing the paradigm. It's not just we didn't just paint ourselves in the corner with, hey, we're just going to have this rectangle that is X dimensions, and then you're kind of stuck there, right? I mean, you can make another version, but then you just have to make it bigger and bigger, right? At some point, you might as well have a car.
Yeah, you can't fit on the sidewalk.
Right, so. Yeah. So then the difference is thinking, okay, what tools could DAX use? And so, a trailer is one of them, and we've got some designs for it. If, let's say DAX wanted to do a circuit, we did a pilot test out at a retirement community, and so not in the assisted living, but in the independent living cottages, being able to how do we maximize that, because it's a very scheduled time frame, right? Everybody gets their meals about the same time, so coming up with a trailer design that could then take a trailer out and do a circuit, so it's not delivering from his belly, but he's got a trailer that has 4 or 5 different orders, in different compartments. Think of like an Amazon locker. I don't know. Anyway, so yeah, there's a lot of people that have asked us different ideas about the delivery component itself, which is pretty cool. And so we've got the ability to then expand to whatever tools, what do people actually need, right? And so now we're in the space where we're commercializing, we've got actual customers, and figuring out what the need in the market is, specifically, like what dimensions do we need? Because if you only sell super jumbo sized New Yorker pizzas, that's very different than, a sub sandwich. So hopefully that answers that question. But in that vein, so outside of delivery, Wilkins, what other next jobs do you see DAX doing, right? Because when we talk about, we built a robot, it happens to do delivery, because that is the biggest human need right now from that perspective. But what other next jobs do you see DAX and other robots, urban space robots doing in the future?
What's one of the things that I love about Dax as a project is his versatility.
Yeah.
So I love hearing you talk about the trailer because early on the reason that we installed a trailer hitch was that Dax was to be in a local Philomath parade. And we wanted him to carry a little red radio flyer wagon, or pull it along, and I believe one of Joseph's kids sat in it and threw candy at it. And then we took this concept of we need to carry a wagon, and we've kind of morphed that into we use this as a trailer, or we've done all sorts of things with that hitch. But speaking to the versatility of Dax, it seems like every time we meet a new person, they come up with a new idea or job for Dax to do. So we came up with a few just while we were brainstorming for making him initially.
Right.
Delivery is the kind of the obvious focal point. Like that's it's very obvious how that would make money.
Yeah.
But we've also talked about, picking up trash on the side of the roads, places, it's not necessarily safe for a human to be out there doing that. Dax could probably very easily mow someone's lawn if they, if someone is elderly and they're not able to necessarily get up and do the yard work that they're used to doing. There's not much stopping Dax from going by and just doing a quick. We have the navigation.
Yep, that's true.
Quick cut. We met just out on an outing one day. We met a woman who worked as a counselor at Oregon State University in the in CAPS, Counseling and Psychological Services, and she was so impressed with Dax as a potential tool to use with nonverbal kids.
Yeah.
So kids who are just don't necessarily don't trust an adult, or they have a hard time connecting with or communicating with their counselor.
Yeah.
Giving this tool for the counselor to kind of place themselves behind the screen of this robot allows better communication with these kids, and that was something we hadn't considered at all, and it just made complete sense. And everyone we talked to, my aunt works in a hospital, and the first thing she said is, wow, this would be perfect for delivering medicine, because usually a lot of these medicines, nurses have to check them out and physically take them to the room because they're controlled substances.
Yeah.
But having a robot that not only has a climate-controlled drawer, but is able to have basic security and authentication built in, that could free up so much time that's being spent couriering things. And just honestly, how we've designed Dax, it sometimes it feels like pretty much anything that a human can do, eventually he might be able to do, is if we play the cards right.
Yeah. The one thing that people do ask is, is Dax going to ever have arms? It's like, we'll see, But yeah, I mean, lawnmowers don't need arms, not these days, But yeah, the pharmaceuticals one. I mean, there's plenty of things. Elevators, even, I mean, it's just Bluetooth technology.
Everything's Wi-Fi or Bluetooth.
Yeah, it's really
pretty amazing. You're hooked into the network.
Yeah,
can do anything.
Yeah, it's pretty cool. Someone asked, so Facebook Live people, this has been fun. So if you have any questions, please put them in there. We had another question that somebody wrote. Could Dax bring beer to someone in a boat? And so I think the question is, can he float? So Dax cannot currently float. He would be very sad. We do have, if you haven't seen there's a post where Sean did, a preview of the environmental chamber that we put Dax in. And I'll give you a fun backstory with that. So when we first built the environmental chamber, we didn't know how much water we should be putting on Dax. And turns out
Oh, that poor robot.
we gave him a lot, and we figured, and for the the Category 5 hurricane that he went through, he actually stood up pretty well. I was pretty impressed. But we got that part figured out. So no, he does not float. So as long as there was good ability to navigate on a dock, and the dock was steady enough, and you're okay with getting off of your boat to the dock, then yeah, Dax can bring you a beer.
We haven't quite gotten the pitching arm.
Yeah,
but
right.
Who knows? Maybe they'll be able to.
The drawer opens.
they can the projectile launchers for T-shirts. Why not beer cans?
Yeah.
Just calculate trajectory.
Yeah, should be fun. Yeah. Is there any other questions that are coming in for us, Miriam? Not right now? Cool. So one thing, back to the versatility piece is because of that, people are always coming up with really cool ideas. And I think it speaks to one of the questions that I get very frequently is sometimes it's a criticism because people don't understand what's going on. And other times it's a genuine question. Is Dax going to be stealing jobs? Because if you're talking about, mowing the lawn, shouldn't the 12-year-old, kid down the street be doing that? It's like, yeah, if the 12-year-old kid wants to, I guess. And so this is something I bring up quite a bit, is that if you look at the Department of Labor and Statistics that the U.S. government has been tracking, so in the United States anyway, since the 1970s when they first started tracking it, the labor force participation rate has been in a steady decline ever since. And by that, it essentially means that, yes, the population is increasing, but the number of people working in relation to the population increase has been in decline, which is interesting. At the same token, like you said, well, delivery makes sense because you also have at the same time, and COVID obviously exacerbated that, that you have the demand where it's almost an expectation now that everything should be delivered to me, right?
Right.
And that, if you would have said that,
Amazon next day delivery.
Yeah, exactly.
From toothbrush to printer.
Yeah, exactly. Everything should come to my door, snap of the fingers. And 5 years ago, that would have been an unreasonable request. It would have been like this. People aren't that lazy or whatever, right? But now it has become. I think again, COVID exacerbated that. So it's not just food delivery, right? It's pharmaceuticals, like you said, groceries, and now Amazon printers, right? You can deliver anything to your doorstep, and in a pretty reasonable time frame, right? So Dax fits that a great space there on the delivery side because you've got the labor force participation rate, you've got the demand going up exponentially for delivery of things, and so at some point it makes way more sense to have a human not do that, right? A human doesn't need to be carrying around a 1 pound burrito inside of a car to deliver to somebody's house when you could have a small vehicle robot do that for you. So that makes sense. The other piece of it too is the transforming of industry, right? So today people aren't too concerned about the vinyl record industry going out of business. It already has, right? 8-track tape came along, that went out of business to cassette tape. That went out of business to CD. That went out of business to MP3. That went out of business to the iPod and now smartphones, etc. So in the same way, as the need for delivery robotics in general increases, you actually do have to have a lot of people employed in that. But it's not delivery drivers necessarily, but it's actually raising the game, if you will, for everybody. And so the guys that we have working for us on the operations side, a lot of them are robotics students or engineering students, which is really neat. I not bashing baristas. I need baristas to keep me going in the morning, but you could get a job as a barista as an engineering student, or you could go get an internship working for a robotics company and actually doing like hands-on real world stuff. So it's pretty cool.
And it's an optimization problem. What we're creating is a tool that where our goal is one operator running 20 robots. So instead of one delivery driver operating one car, it's that same person could be operating 20 robots and doing 20 things at once. And it's about making tools to make our lives more efficient so that maybe we don't have to work as hard.
Right. Yeah. So one question that came through is, how am I driving stickers on DAX? That's a very fun question. We actually do have stickers on the back of most of it's not on DAX himself, it's on the battery. But the batteries are essentially have to do with mapping. What am I doing, not necessarily how am I driving. So what am I doing? And especially when we go to new areas, I got the chance to go down to Coronado a few weeks ago, which was fun. That's right outside San Diego. And in Philomath, everybody's getting kind of used to DAX. Usually, a tourist will drive by and be amazed, but a lot of times, it's just DAX. It's just the friendly neighborhood robot, which has been fantastic. I mean, the outpouring and the love from the Philomath, for as far as especially in the financial raise, and now seeing DAX go different places, they're like, hey, that's our robot. Philomath is really, they love DAX. But then going to Coronado, it was a spectacle. I mean, I would walk with the robot for a couple hours, and it's not an exaggeration. About every 10 minutes, somebody would pull over to the side of the road and want to have a conversation with me about it. What is that thing? That is so cool. And Coronado, there's a lot of people that are entrepreneurs down there, and they were fascinated by it, and so it was very neat. So we don't have how am I driving, but we do have what am I doing, and then that QR code then links back to one of our pages. And if somebody wants to get a hold of us, they can. There's going to be phone number there, stuff like that. There are actually laws in different places that we're going to. Where we actually have to put a phone number, on the battery, so that if somebody wants to call and talk to an operator, I guess they can call and talk to an operator. But yeah,
I think that's a super interesting question because can I talk about
Absolutely.
how that thing works?
Yeah.
So the way that we're achieving this 20 operators, or not 20 bots, one operator.
Yeah.
Is So the robot has basic safety systems. Like he won't run over something that's solid. He can perceive depth, and can see that there is an obstacle in his way. And then how he navigates is with GPS, because that is remarkably accurate. It can get down to centimeter accuracy in good, bright, open sky, and then when he is indoors or otherwise the signal is obscured, he can then integrate his inertial measurement unit and know exactly where he is until he gets another good GPS fix. And so we leverage this by the first thing we do when we get to a new town or a new deployment is we go out and we lay down lines. So operator manually drives the robot and essentially shows him where he's allowed to go. Like what does the sidewalk look like?
Yeah.
What are the precise lat-long coordinates of this intersection? How there's a pothole here, so in the future you're going to want to navigate around that.
Yeah.
And we mark these lines with different hazard levels. This be careful here, go slowly because it's gravel. But this is some really nice pavement. We can go like 2 meters per second easy.
Yeah.
And then once we have this kind of infrastructure of lines laid down, we're able to use the I hate to call it the oldest trick in the book, but any RTS, like old school RTS that has pathing, once you have your network, it's a traveling salesman problem. It's
right.
You tell the robot go from here to here, and then it goes there. Like,
yeah.
Just like your RTS sprite in StarCraft, the original StarCraft.
Right. Yeah. That goes back a ways. Yeah.
So it's interesting thinking of how am I driving stickers on DAX, because theoretically this robot could be driving the same line that was laid down a year ago.
Yep.
And tweaked slightly to deal with maybe there's a detour due to construction, or maybe that road has just gotten too beat up, so we go a different route. But it's how are we driving when ideally, like our goal is to make sure that he drives the exact same way every single time.
Yeah, and so I'm guessing, presuming that question came from somebody in Philomath, where they see robots driving all over the place, doing all sorts of fun things, especially behind the shop here. This road that doesn't go anywhere. And so, we're always doing fun tests out there, especially when it comes to autonomy. It's like, oh, what happens if we do figure eights and you try and flip them upside down? No, it's just, yeah.
How high of a ramp can we go off before we break the bottom?
Yeah, it's not that high.
We have a few good in the air pictures of Dax.
Yeah, and usually accidental, right? Anytime we go somewhere for the first time, like you said, somebody has to drive him. Right. So we're making sure that we're not run over stuff.
Oh, that was a bump, wasn't it?
Yeah, or there was one that the sidewalk just disappeared, and fortunately, Dax is going fast enough that he actually got some air, but he landed and kept going.
Yeah,
surprised the operator, but. It was good. Somebody asked, I guess in the same vein, how does Dax do on snow and icy sidewalks?
Pretty well, actually. I think we've had either one or two major snowfalls since Dax has been out and driving around, and the hardest thing about it is that it becomes very hard to tell where the curb is.
Right. Yeah.
So that's not a problem when he's driving autonomously, because he's following the GPS coordinates.
Right,
so he knows where the sidewalk is underneath this inch of snow. But when the poor operators get up to cross the road, because they usually take over for crossing intersections, because we want him to look both ways and have someone actually looking.
Yeah.
When they get to that point, they have a hard time figuring out where their little ramp is.
Yeah.
And so we've had a few problems where they've misestimated and just dropped off a curb, and there's just this thunk, which usually the robot is fine with, but on occasion it's caused problems.
Yep.
But just driving on snow, he's got these all-terrain treads, and he is fine. We haven't tried it on a frozen lake yet, but we should definitely add.
That'd be fun. And we could put some studs, in the treads. And should be good. I joke with the guys. So I originally grew up in Montana, and when we get snow, we can get feet of snow. So I don't think we've seen Dax in that yet. But going back to that is actually an application that I see big time. Is being able to put a snow Dax grabs a snowplow and starts shoveling snow for people.
And that's not something I would have ever really considered because I'm from North Carolina where we don't have very deep snow.
Yeah.
Just talk to another person.
Yeah, exactly. It's
another job.
Pretty cool. So I want to talk about a little bit about the financial raise and stuff like that we've been doing. I mentioned it a little bit. Is that the outpouring, the love that we've gotten from Philomath has been pretty cool. And I think it comes down to the fact that when people see Dax and actually experience it, to be very honest, right, in the computer graphics world we live in today, it's very hard to look at a commercial and see what is that, you know what I mean? What is actually real and what does what is not, and so it's
what's
very
been computer generated.
Yeah, it's very easy to fake stuff. So when people see Dax, even on, I'm guessing, even if they've never seen him in real life, they just see a YouTube video or something like that. They're like, oh, that's cute. Somebody had fun with CGI until they're actually on a sidewalk, right? And this robot actually comes down the sidewalk towards them, and then that's a totally different experience. And so we're working on getting Dax more and more into places like that. I got to go down to Coronado. That was a lot of fun. He was in Los Angeles, last week or two. But even, taking him to Portland and places,
right.
Just taking him out, and so people actually seeing it's a real thing. That's one of the things when people ask, what's a differentiator with your company. One is that we actually have a product. There's a lot of startups out there. I'm sure when you work in California, you run into a lot. There's a lot of startups out there that really have a really good idea, like this burning passion. And one, they either don't have the technical aptitude to actually pull it off themselves, so that's a barrier. Or two, it's just a great idea, right? But actually having it's actually a product, right? It's actually working for people, which is pretty cool. So moving forward is I'm asking people a lot of times, right? Even personally, hey, would you invest in Dax? Because it has more to do with like this is the technology. We believe this is where the future is going to be. Even people like Amazon are saying, there's definitely going to be a robot in every house in the next 10 years, right? So it's not like it's a far-fetched idea anymore. I think if you would have said 20 years ago, robots are going to be delivering food to people, that would have been hard for people to understand. But 20 years ago, we kind of had the internet and we didn't have smartphones, right? So I mean, technology has changed so rapidly that it's definitely the place that is moving forward. And from the human acceptance standpoint, because I get to work on the laws, working with the governments and whether it's state or local or whomever, helping shape policy so that you don't paint yourselves in a corner, right? And there's some laws that are coming out there. It's like, okay, well, you can have a computer as long as you don't put it in your house. I mean, it's those types of absurdities that we would talk about today. It's like, well, of course we need computers in our houses, right? So helping form policy, and a lot of that has to do with the human acceptance piece. As I'm asking people, people that are on live or see this later, if you have invested in DAX, first of all, thank you very much, because it's very cool. Miriam talks about the DAX fam all the time. If you know people that want to invest, I'm happy to jump on, hour-long conversations on Zoom one-on-one with people. I've got one scheduled tomorrow, so happy to talk, more deep into the financials and stuff like that. I didn't want to do a lot of that today with this platform. This was more fun just to talk about the engineering and the funness behind it. But I would definitely encourage people to, if you haven't invested in DAX, please do so, and check out startengine.com/DAXbot, which has all the information as far as the financial raise is concerned. We did have another question that came in, as how does DAX do with Chicago, New York temperatures? Cold, I think is what you're talking about.
Cold is great. Electronics love cold. It is so efficient to generate heat. It's just a matter of taking a resistor and running current through it. Like having DAX be in a cold environment and keeping things warm is super easy. It's the other side that
Death Valley.
That's the harder problem to solve, because we have this we have a Jetson Xavier in the head that generates 20 watts of heat, and
that's a lot of heat.
You can only evacuate that so fast. I mean, cold is great. Dax loves the cold. There's some concerns with battery chemistry. So if I remember correctly, lithium-ion safe operating discharge temperature is only down to about 20 C. So you're not actually supposed to freeze your lithium-ion batteries, just in case. So there are some sort of chemistry concerns like that, but that might means we might use a different type of battery, or have some sort of heating element that keeps the pack warm, and stuff like that.
Just more hurdles to overcome, challenges to figure out. So I'm actually I think again, Montana gets super cold, so I'm excited to have Dax hang out in some super cold temperatures, and just see he freezes over, and I'm kidding. Bring him back to life like a mammoth. No. I didn't have anything else. Was there any like closing thoughts or any things you want to leave us with, Wilkins? I don't think we've got any more questions coming in from the live, but
there's one question that I've had in the past that I do want to address.
Sure.
So someone in the past has asked how has DAX kind of integrated both art and creativity and science. Because we often talk about like the engineering aspect, but we don't often talk about the the actual design creativity of how we came up with this shape, or this particular set of expressions. And I've always thought it was an interesting question, and we actually spent quite a lot of time. A friend of mine who was double major in physics and art. We hired him to come run an experiment where he created several different types of static images of expressions and faces and things like that. And then he ran an experiment and introduced several employees and friends to these images and got the reactions. So it's what we were trying to figure out is, what does Dax need to have as far as eyes in order for people to feel like he's connecting with them? So, the things we started out with projectors so that we could actually move the image around and kind of organically, like have a pupil that moves within the iris, so to speak. And what we learned is that honestly we get a better response with the sort of almost anime expressions of wide eyes, wide fixed images. And it was just such an interesting experiment going through it. I remember the best part of it is we went through several different. He got a bunch of paintings and things from Goodwill. He got some sculptures, and in the end, the thing behind the curtain was himself just staring at you. And all the while, you're supposed to be filling out how does this make you feel?
Yeah,
and that was a really fun experiment. And we've cool. The whole time, this human robotic interaction piece, it a lot of the time it just feels like playing around. Like we get to do these fun things. How much does Dax need to tilt his head and put on hard eyes so that you really feel the love?
Yeah.
How often should he blink? There are all these kind of small little things that we've had to tweak over time just to make him feel more alive.
Yeah. Yeah.
Speaking of alive, one of the things, all of his movements are actually sinusoidal. So generally,
what does that mean?
Sine wave. So half a circle, sort of.
Yeah.
So normal motor control is trapezoidal. You accelerate linearly up to a point, and then you hold fixed, and then you decelerate to your destination. We did a lot of work. Joseph actually strapped an accelerometer to someone's head, and we did a bunch of work modeling, what does organic motion look like, and then we integrated that into a library, and his neck motions and some of his fixed movements are using that sinusoidal motion algorithm.
Wow.
And it's just little things like that.
Yeah. A funny thing though, I mean, you're talking about little things like that because when I've talked to people that want to rent DAX or have DAX for deployment, and they've got some computer science background, and so they think very much in that box of computer science of oh well, the robot should do this. How come he doesn't have LiDAR? Right. For example, right? We didn't want him to have LiDAR.
Yeah.
Right? There's
you don't use LiDAR.
There's some very specific reasons why, or DAX needs to have flags. It's no, he doesn't. I guess one of the, and this would be an interesting question because people talk about this a lot. Is there a backstory to why Dax doesn't speak in language? Because people ask me that. Actually, one guy was kind of irritated. He's like, "What do you mean Dax doesn't speak in language? You should be able to."
We're trying to. Joseph has coined the term canamorphic, so canine-like, dog-like.
Canamorphic, yeah.
And we're trying very hard to avoid the uncanny valley of the robots that are they're a little too human-like. We're trying to make Dax more dog-like. He maybe he does a little spin when he sees you, or he makes whacks his non-existent tail, makes an expression or tilts his head. A dog is able to communicate very well with people that he's non-threatening, he's interested in you, that he sees you're there, all of this non-verbally. And we felt that we would create a better analog of that if we just from the beginning said no voices.
Yeah.
So we worked with a sound engineer and created a few different sounds that we feel help communicate a mood, and then we have various expressions to support that. But our goal has always been, we don't want a human voice coming out of this, except in very specific potential situations. Like one of our ideas was Dax, the roving AED.
Oh yeah,
and like as an intercom. With
him.
So he's
opening your
talking,
door and you have an AED and being able to connect someone to 911, or even AEDs now have automated instructions on how to go through them, and just the ability to have this platform that could connect you to an authority figure if in the security or emergency situation.
Right.
That is something that we're interested in pursuing, but not for normal interactions.
Yeah, that makes sense.
We want to make sure it's clear that when you're talking to Dax versus talking through Dax.
Yes. Through Dax. Yeah. Dax is now your telephone. Yeah. Right. Yeah. Well, Wilkins, thanks for taking some time and doing this. It was fun hanging out with Joseph last month, and it was fun. Hearing even just some backstories, because I'm catching up as well. Just all the back stuff. That sounds like something Joseph would do. Like, here, just put this accelerometer on your head.
Yep.
And I want you to run around. And
it was this foam helmet.
That's so cool.
Yeah, I think he might have put plastic wrap around and just put some spray foam.
I'll see if Miriam has a picture of that, because that would be something
we probably
bring
have
out of
it
the
here.
archives. That'd be really fun.
We'll have to ask him.
Nice. Cool. Well, thanks everybody for joining us, and we'll sign off.
All right.
See ya.
Thanks.